Last time we have mentioned that now we see a gas as a lot of molecules moving in random in very high speed. So that now scientists try to form a real-life model to help us to understand what is going on inside the gas, how we can see the microscopic world. We have the kinetic theory model, which got a large number of beads, that is some small balls inside, is set into motion by a vibrator here. Here we got a vibrating platform with a motor, so that the motor will be always pushing the platform and to set motion for the beads to move around in very high speed. And this is being trapped by the piston inside this model, and then by varying different things like the weight added of the piston or the power of the motor, then we can stimulate the change of general gas law, and we have to somehow recite it. Need not to be word by words because it is not explanation question, but then at least you have to know what is representing by different things in this model. Like in this model, the small bits is representing the gas molecules, and then the height of the piston, that is the volume of the container trapped it, will be the volume of the gas. The weight of the piston will be the pressure of the gas, so that if you have more weight, you will be pushing in a greater pressure here, and this is the volume, and the small bits will be molecules. And lastly, the power of the motor is in fact the temperature, because when the power increases, the molecules will be faster. That means you have a higher temperature stimulating, so that the motor is related to temperature. Somehow beside this will be okay because it is usually MC. And next, we will be going into explain by using kinetic theory. This is super important in DSE, because you really need to explain this in explanation question. Please really recite it words by words. Exact wordings is needed for a very accurate explanation. And in this, you will be covering 4 types of explanation. The first one is Boyle's law. Second one, pressure law. The third one, Charles's law. And the last one is a general pumping of air. Just this 4. And I have listed out all the exact wordings explanation, copying and summarizing from DSE, so that you just really need to focus on the exact wording I display to you. And we will be focusing on different criteria here. We will be focusing on molecular motion when you're explaining by kinetic theory. You talk about molecules, about their elastic collision with the wall of the container, which generate the pressure and which depends on different things here. You can imagine by using the kinetic theory model, if you have more molecules, then you must have higher pressure. If you have less volume, again you have higher pressure because it is denser for the gas. And the average speed of the molecules, if the average speed is higher, then obviously the pressure increase. The frequency of collision, that is, if you have the same speed but then your frequency of collision of the wall is higher, then obviously you feel that the pressure will increase. And lastly, the momentum change. If you have a higher momentum change, that is, you are faster and you are heavier and being rebound elastically, then your pressure will be obviously greater. And please really recite those important new wordings for yourself. When you're talking about frequency of collision, you talk about it collides more frequently, and then for momentum, then it will be colliding more violently and less violently if it is slower. So that in general, you will be explaining in terms of this, and 2, 3 will be quite important, and 4 and 5 will be always appearing. Then let's try to see how to explain one by one by our very familiar Boyle's law. In our Boyle's law, what we are doing will be we compress at constant temperature. So that what we are doing here is we try to look at the situation. We keep something the same, we keep the temperature the same. We use this symbol, this special bracket, to show that something is kept constant. Okay, and we can continue. When we are explaining, we have to say this is being compressed at constant temperature, so that if the temperature is constant, the average speed will remain unchanged. And we must be talking about the average, because different particles will be moving with different speed. Some is faster, some is slower, so that when we describe the whole gas, we use average speed will remain unchanged, so that we know that the average speed is remain unchanged. Now, those will be kept constant, and this is being compressed so that the volume decreases. As the volume decreases, the molecules will hit the wall more frequently, because it is now denser, so that with the same speed, the frequency of collision increases, which leads to the pressure will also increase. Then this is it for the explanation. And sometimes, furthermore, the question may further ask for the change in density in some explanation question or MC. Then for density, you just need to focus on one thing. Very simple. When you're talking about density, you just need to look at the volume. So that when the volume decreases, the molecular separation decreases, because this is being trapped, so that the amount of molecules inside is exactly the same, and the volume decreases, so that the density must increase. Okay, so that now you really understand, when you're talking about density, you look at the volume. They link up each other. Alright, and then let's focus on some important wordings here, like what is the initial situation? Compress, constant pressure. You have to focus on this. What is being changed? What is being changed, and what is being constant? In this chapter, even if you are explaining or calculating, you have to focus on what is being changed and what is being constant here. Okay, then this is the situation. The change is we try to compress, and this is the whole starting point of the question. We compress it. Okay. Next, the second one will be about heating. This time you are heating at constant volume, so that this is being changed and this is being kept constant this time. Okay, and what you are doing will be you are firstly heating this, and this is the whole starting point of the situation, so that when we are heating with constant volume, what we are changing will be the temperature is increasing. Then we explain, as the temperature increases at constant volume, the average speed increases because it becomes faster. And then as the volume is fixed, the molecule will hit the wall more frequently and violently at the same time, because now it is being faster, so that it can travel inside in a faster speed, so that it will hit the wall more frequently. And at the same time, because the momentum now is greater, so that the change in momentum is greater, and we describe it as more violently. Therefore, the pressure increases. Then that's it for the explanation. And further, we may talk about density again. As we have mentioned, when we talk about density, we just look at volume. Volume is the same, so that when volume is the same, density is unchanged. Then we can also describe it by some simple symbols. When the temperature increases, the average speed increases, therefore the frequency of collision increases, and the change in momentum also increases. And this finally leads to the pressure will increase. It all starts with the heating of the gas. 3. Now we try to explain heating at constant pressure. Temperature increases, now P is being kept constant. So that we have P constant here. and the temperature increases this time. Then we try to explain. Temperature increases at constant pressure. Again, average speed increases. Then again, the molecules will hit the wall more frequently and violently again. But then now, we don't want to change the temperature. We have to maintain the constant pressure this time. So that in order to maintain constant pressure, the volume must increase so that the frequency of collision is being reduced. At the end, when we increase the temperature, we increase the volume, in fact. Okay? Then this is the situation. And further, we may talk about density. Again, this time the volume is increased so that the density will be decreased. And we use some simple symbol here to help us. Temperature increases, average speed increases, frequency increases, momentum change increases, pressure is in fact increasing. But then to maintain constant P, what you need to do is volume must increase. So that's it for the whole situation for Charles' law. And lastly will be about pumping of air. This is not about those laws, just pumping of air. And we kept something constant, so that we increase the number of molecules and kept temperature and kept pressure constant. We kept T, we kept P constant, and we increased the number of molecules. See what happened. When we kept constant and pumping of air, average speed is unchanged. Also, the change in momentum is unchanged, but then this one can be a little bit outside our answer. We just mentioned average speed unchanged. And then we mentioned number of molecules increase. What is the effect? Will be the molecules will hit the wall more frequently. This time you can see only frequency increases, but the change in momentum is being kept constant because it is not faster and the mass is not changing, still that particular molecules. Okay? And now if the frequency will increase, that means the pressure is increasing in fact, but then now we want to maintain a constant pressure so that again volume has to be increased so that the frequency of collision is reduced. Therefore, the pressure can be kept constant. So that we try to use some symbol to help us to understand. N increases, frequency increases, pressure increases, but then to maintain constant pressure, what we need to do is the volume needs to be increased. Okay? So that lastly, again, we talk about density. As the volume increases, then density will decrease. Then density, just look at volume, very, very simple here. Now, I want you to try to add in some more thing here. On top of T kept constant, in fact, you can further say that average speed is constant and also the change in momentum for the collision is also constant from T equals to constant. Okay? And that is how we can explain these four very important and very common situation. And as long as you learn all those important physics wordings for explanation, try to recite it, then you will be super good in explaining. This is a difficult part, but then now we can recite just several points for different situation only, and they are super similar. Please really try to recite it. And lastly, MC may also ask for, now we know the situation, can we try to use the kinetic theory model or this real-life model to stimulate all these four situations? The answer should be yes. And the key point will be, as long as you remember what is the component of the model representing the property of the gas, then you can follow all this concept here to try to explain what is going on. Like, we will go through it real quick here because you should try to read it and understand it by yourself. For Boyle's law, this is the first situation, second, third, and the fourth situation representing before. About pressure law, Charles' law, and pumping of air. Okay, then we are compressing again, we are heating and heating again at constant pressure, constant volume, constant pressure again. Now this time is constant pressure and temperature, exactly the same as what we have mentioned. And how to do it in kinetic model, this will be new for us, and you just need to know this, and all those will be followed. What we are doing here will be, in order to stimulate compress, we add in piston to decrease the height. So that when the weight of piston increases, height of piston decreases. That means volume decreases. And then collision frequency will increase so that the pressure will increase. Same as before. And on increasing voltage, that means the temperature increase, heating. Add piston to keep the height unchanged because we want constant volume. So that when voltage increase, speed of molecules increase, that means we're representing temperature increases. And then collision frequency and the force, that means the change in momentum will increase. To restore the original height, we have to add in some weight so that we have pressure increase at the end. Increase voltage to increase height. Increase voltage means heating, so that the speed increases, temperature increases, and then the collision force increases, height of piston increases, that means the volume will increase. That means the frequency of collision will decrease. But then we now want to keep the pressure constant so that the effect of collision force increase is balanced by the frequency decreases, so that at the end the pressure will be constant. That means we are not changing the weight of the piston. Lastly, we add in some more bits, then the height of the piston will increase. That means the volume will increase because when number of molecules increases, frequency of collision increases, height of the piston increases, representing volume increase, and the frequency will decrease, so that the pressure can be kept constant here. Okay, then that's it for the kinetic theory model, and also how to explain by using kinetic theory, which is super important. Okay. And I want you to try all the upcoming MC and also some explanation question. Now sometimes the question may be a little bit different so that you cannot copy directly, but you have to use the concept and the wordings to try to explain. All these 4 questions are explaining by using kinetic theory.